Hey there. Okay, so this week we've got another tool. We're going to talk about static this time. And to kick things off, we're going to go directly to Owen. Owen, want to get us started with talking about static?
Yeah, Carl. Um, Static analysis is a crucial step when developing software. The main reasons for that are catching errors early. So, waiting for errors or bugs to show up after deployment is going to be far more costly in terms of money, time, business reputation. So, instead of that, static analysis during the deployment pipeline can help to catch many of these errors and prevent the deployment of defective code. So, an example of defective code would be an arithmetic error, a memory access error, or accessing outside of the bounds of an array. So these are runtime errors that can be caught ahead of time through static analysis. Static analysis can also help to improve the best practices with your programming. So static analysis is heavily rules driven, and rules help to ensure compliance in certain industries. And static can automatically check these rules and find non-compliances in the code. And the result of this is that developers can learn from the tool and improve the code that they write. And the tool can provide a guideline for correcting those defects. So it can make both finding and fixing the problems quicker. So this will help to save time and money in code reviews. So manually reviewing all code for style, rule compliance, logic, and security can be extremely time consuming. But with the static analysis tool like Static, you can track the historical data, who's reviewing what developers writing the code, who's commenting, and the conversation that happens back and forth discussing the issues in the code. So this helps to build a knowledge base for the team to reference in case the same issue comes up again in the future. So Static can handle some of this manual reviewing automatically. And this results in helping to catch errors as far upstream in the deployment and development process as possible. And another aspect of this is that high false positive rates for static analysis tools are bad. They waste time. You have to check each detected defect and decide if it is really a problem and whether it should be fixed or not. And so a high false positive rate will cause excessive amounts of time being wasted here. But our tool Static has a very low false positive rate, so you'll actually save a lot of time relative to our competitors' tools. So now I'll let Amol talk about some of the industry-specific regulations.
Right. Thank you, Owen. So what Owen just covered is the general benefits of applying static analysis. There's certain applications of applying static analysis by regulation because it's required. This primarily happens in mission critical industries, which is what we specialize in. So the industries that we would cover just by example, for example, in automotive, you're required to follow MISRA C, C++, which static will cover. In aerospace, you have to abide by either DO 178C or JSF, which static covers. For security, many developers are aware of CWE and cert requirements. For railroads and locomotives, there's IEC 62279 EN 50128. For power and electric, IEC 61508. For the medical industry, IEC 62304. And for nuclear, we have IEC 60880. So static can cover all those regulations for a wide range of industries, which may be required for the software that you're making. Another neat thing about static is that you can have custom rulings. So if you're not in a particular industry, or if you are in a particular industry and then you as an organization have other requirements above that, so naming conventions or limits on your code quality metrics. So for example, there's a metric called psychometric complexity or coupling of a class or cohesion. These are all just metrics of your code. So you can have the tool evaluate these metrics and then place maximum levels on these custom to your organization, which also helps improve code quality quite a bit. So that's as far as it goes for applying different rule sets. So you have the base rule sets based on your regulations of your particular industry that you're developing the software in, and you can build upon that based on any rule sets that your organization might have. So now I'm just going to cover the new improvements that we made in the coming year of static. So in a case study for a particular automotive client that uses static, we increased the application of their rule set to 96.12%. So it covers the vast majority of the rule set automatically. And that's for C, and for C++ 95%. And it covers 100% of their high level severity issues that are in their rule set. So that's using both the main MISRA, so for automotive, the base, and then any additional rules that they built custom to themselves. So you have high likelihood of being able to catch any of your flaws in the code based on the rule set that your organization has. And then also there, we made a handful of UI UX improvements to make it easier to use, more user friendly, easily understandable, and then the features that are easily understood. But and the features that Owen talked about for code review and things of that nature can be done pretty easy. And that's all we got.
That's pretty amazing. Actually, I was thinking that we had a lot to cover, but actually it's pretty comprehensive and pretty precise in terms of what we talked about today. So that's fantastic. So thank you both for doing that. And if anyone has any questions about either of the tools we've talked about so far or this particular one, please feel free to reach out to us anytime to ask those questions. We'd be more than happy to help you out. So until next time, thank you very much, and we'll talk to you again soon.